Hello, ladies and gentlemen. This is Mr. Heeren coming at you whenever it is convenient for you through the video or through your notes video. And what we're talking about today is start of Unit 2, Lesson 1, kind of what introduction to a radian is. Now, a radian, I really hope you notice that it sounds a lot like radius, and those two are going to be related. So if your mind jumped immediately to radius from radians, that's good. So we're going to look at what one radius is, and then kind of think about converting between radians to degrees and degrees and radians, because while they're related, they're not exactly the same. So let's kind of get into what we're dealing with here. So don't worry about this. We were going to do this as an in-class activity, but we're going to skip it for right now. So the main idea is this. Okay, you're going to forget about this. So what you're going to realize is that a radius, whatever that length is going to be equal to a arc length. Okay, so if your radius was 2 centimeters, then this would be 2 centimeters. If your radius was 3 centimeters, then this would be 3 centimeters. So, obviously a radius of 2 centimeters would be one length. 3 centimeters would be a little bit bigger. So as the radius gets bigger, the radian, the arc length, would also get bigger. So what you're trying to realize is that it's like somebody took this length, whatever it is, and then laid it down on the circle. Okay, so you take this length, you physically pick it up, and then you lay it down right here, curve it around. That is your arc length. Okay, so what's the punchline? Why are we doing that? So if you take 1 radian, all right, so just kind of imagine that you've got your circle, you've got your radius. I can't believe I just almost misspelled radius. So you've got this length, R. So then I pick it up and I go this length, R, on the circle. So then I measure out that angle. So now what they're asking for, what would be this angle? How big is that angle? Well, if I use that my angle, no matter what size circle I have, so that's always going to equal 57 degrees. So anyway, back to where I was saying. Sorry about that pause. So this is always going to be 57 degrees. Okay? Always. No matter how big the circle, so you can have different size circles, but no matter what, that's going to be 57 degrees. So when you lay this out, how many radians does it take to make one full revolution of a circle? So if you take 360 degrees divided by 57, that's going to be approximately 6.3 radians. Okay, so if you take your circle, that's your length R. If you go R, 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 all the way around, you will have a little bit more than 6 radians. And kind of the big idea is I want you to realize is that that's approximately going to be 2 pi. So 2 pi is going to become important here, okay? So you're going to want to remember that. So 360 degrees is going to be equal to 2 pi. Or not equal, but equivalent. So make sure you have that highlighted somewhere in your notes. Okay, so what are we trying to do? Oh, one more thing I want to mention. I'll slide over here and do it. This is a different way of measuring around a circle. Okay? You're familiar with degrees. Circle equals 360. Okay? What you have to realize is that this is you spinning in a circle, and each time you go around, it's 360 degrees. So one way to think about it, if this is a merry-go-round, you are standing in the center and you are spinning in a circle. You measure how much you spin in degrees. That's what you're measuring. Okay, that's what you're used to. Now, how is radians different? So radians, I don't know why I keep misspelling that. Radians is different. It's measuring your distance. So what's this measuring is you're on the outside, you're on the horse, or whatever animal is on the outside of the merry-go-round, and you're measuring how far you're going in distance. Okay, how much around the circle are you traveling? That's the big difference here. Okay, you're looking for, first off, you're looking for how far am I going in a circle? That is your question. All right, so that's kind of the big idea. So you're trying to convert between spinning in a circle versus how far you're going traveling in your distance. Okay, so let's kind of go with this. So here's what this is saying. So I want to use this conversion factor. So this is important. So make sure that this is kind of your idea, to go from degrees to radians. Remember, degrees is your spin, and then your radians is your distance. So it says convert 25 degrees into exact radians. So exact, once again, means no decimals. So what I want to do is this. I'm going to take my 25 degrees, and I'm going to multiply it by pi over 180. I'm going to use this conversion like so. But now I do that for I set it up like that for this reason. What I need is degrees here, so I need degrees on the bottom over here. Okay? So I'm going to take 25 times pi over 180. So now a little bit of simplifying. Divide those both by 5, and I get 36. So my simplified answer will be 5 pi over 36. That would be my distance in radians. Okay, so it doesn't matter how big the circle is. Whatever that is, it's going to be 5 pi times the radians. All right? So what I'm looking at is this. I'm going back and forth between my distance and how much I am spinning. So if I take 122 degrees, I want to multiply that times pi over 180 degrees. Kind of a good way to think about it, and if you've ever done chemistry conversions, is that you cancel out this and this. And in those, you've done kilometers and things like that. So you can do it that way. So what you're going to have is 122 pi over 180, and then solve that. So 122 pi over 180, all you can do is divide both the top and bottom by 2. So you get 61 over 90. So it'll be 61 pi over 90 radians. And again, big picture. You're thinking about this is how far around the circle that you have spun. That's all you're looking at right now. So kind of jumping backwards, now you're converting this to this, and you're trying to figure out what's going on. So now you've got your distance around the circle. How many degrees did they spin? Well, you're going to do 16 pi over 3, except now you're going to multiply it by 180 over pi. So this is in radians. So I need to put radians down here. And a good check to see if your setup is right is, can I cancel pi? And the answer should be yes. Okay, the way I have this set up, pi should be able to cancel out. Okay, that is my giveaway. On the other one, I should be able to cancel out degrees. On this one, I should be able to cancel out the pi. All right, so here, if I do some canceling out there, that's going to be 60. That's going to cancel out. So 16 times 60 should give me 960 degrees. So 16 pi over 3 is 960 degrees. So that's spinning about 2 full circles plus about another half of one more. So again, all I'm doing, converting this to degrees, my check is to have 180 over pi. So again, can I cancel pi? That is my check. The answer, yep, I can do that. Pi's cancel out. 180 divided by 4. 180 over 4 is going to cancel out as well. 180 divided by 4 is going to be 45. So that's going to be equal to 21 times 45, which should be 945 degrees. Okay, so all I'm doing is converting back and forth. That's it. Okay. So now let's take a look. So try and do this without a calculator. Try and do some mental math here and see what you find out. What I want to do is see if I can go from radian to degrees. So radian 2 degrees, remember my check is, can I cancel pi? So cancel pi here, 180 over 2 should equal 90 degrees. Part 2, pi over 6, again, that's 180 over pi. I can most definitely cancel out the pi's, so 180 over 6 should be 30 degrees. And pay attention to this because this is going to show up later. So recognizing pi over 2, pi over 6, and especially pi over 3. The third one's going to be pi over 3, so make sure that you can recognize those. So now flipping it around, see if I can go from degrees, 45 degrees, 60 degrees. Those are popular ones. Those are ones we've dealt with before. And you're going to kind of go the other way. So this time, remember, all right, you're going pi for 180. So can you cancel degrees? So 180 degrees cancel. So I'm left with 45 pi over 180. But I can simplify that, and that's just going to be pi over 4. 60 degrees, same idea. Cancel out degrees. That simplifies to pi over 3. See if you can do that without any problems or any issues like that, without having to use a calculator. Come on, have some mental math about you. You can do it. I have faith in you. Okay, so figure out what 1 radian is. Remember, that is 1 radius length around the circle. Radians 2 degrees. Remember, you've got to take radians 2 degrees. That's where you got to take 180 over pi. And degrees to radians, that's where you got to take pi over 180 and use that in some way, shape, or form. All right, so that's your assignment. So now I want to kind of look at your assignment. I want to kind of make your life easy and chop some things down. So here's your assignment. All right, so what I'm going to say is this. You can skip this part. Let's say you can skip this part. I want you to do this part. And I will say you can skip this left-hand column. So only do these 6. Then that's the front side. So start with that. On the back side, just to keep with consistency, I'll say you can skip those. Then I want you to definitely do these 3. And then here, skip that one. And that one. You don't have to do those ones. All right, so we're going to kind of dwindle it down, make your life easy. All right, so if you need to talk to me one-on-one, then we can definitely set that up. Just let me know through Schoology or through email kind of what's going on. Otherwise, I should be able to talk to you this afternoon in some way, shape, or form. Anyway, otherwise, good luck. Take a look, and don't be afraid to reach out to me for questions.